Welcome folks. Today I was going to be talking a little bit about the General Motors high energy ignition system that's built right into the distributor cap for most V8 engines that the General Motors produce, whether it was a Chevy, a Buick, an Olds, a Pontiac. These ones generally took over from the smaller cap with a separate ignition coil. About 1975 they started using these in production vehicles in North America. Okay, what you see before you here, I'll actually back it up a bit. I've got it, these are just some spare parts I had left over, and it's not complete, so I'll explain it to you. Normally you wouldn't see the coil on top of here. Oh, by the way, this is quite a large diameter distributor cap. It's about 5 inches in diameter, so it's quite a bit larger than most distributor caps that have the separate coil. Okay, so I'll just put my hand here, and this, you won't even see the coil at all because there'll be a black plastic cap. And on top of that there will be a ring with the 8 spark plug leads coming from each of these towers, and it secures. There's a bit of a knob or nipple, if you will, on top of each of the spark plug leads, and there's a plastic ring that goes around here and has 8 holes in it rather, and they clamp down and secure this thing, and then there's usually 2 latches here that secure that ring and hold the spark plug leads in place. In future videos, if I can get a hold of some parts, I'll make another one and show you exactly what that's all about. But today's installment, episode, is going to be about measuring your ignition coil with an ohm meter to check out to see if it's still functional. Okay, so we'll break it down now. We've removed the ring with the 8 spark plug leads. There's like I said, there's 2 latches here usually, and you pull the whole ring off and all 8 wires come off with that ring. And there'll still be another cap on here. It's usually black in color to match the cap. And there's 2 screws that secure it. One here you can see. Might even be 3 on this, but I just remember 2. There could be 3. It shows 3, but whether it's 2 or 3, you just look down in there and make sure you get them out. And then the cap just the black plastic cap just lifts off, and this is what you'll be faced with here. We're still minus one more thing. I believe there was another connector wire with a spade clip that goes down in between these 2 here. Okay, I'll be pulling those out and putting them at 90 degrees so you can see in the video quite a bit better. This one here is just a ground wire. Also, before you can take, if you really don't have to measure this with the coil out. I'll show you both ways. I'll start with the other way first, but I'll just explain a few things going on here before we flip it over. So there's 4 more screws that screw down into the plastic housing on top of the distributor cap here. And this is a ground wire for the secondary side of the coil, I believe. That gets screwed down in there tight to make the connection. And then I believe there might be another one here with a short lead on it that goes to another spade clip for your ground connection. Now from the distributor housing there should be a 3-wire wiring harness coming up, and it connects to the bottom of this area here. There'll be a cap covering it, but it's much the same shape. Okay, now with all that said and done, we'll flip this over and show you the easiest way to test it without having to remove all of this. You can actually do this without, if you can flip this thing over with the spark plug wires on it, you can probably just do it that way too. But make sure there's usually 1 wire here that connects to this side over here where my finger is. And that's your battery supply lead. It's usually got a red wire on it. You just compress the clip and remove that. Okay, that's going to have to be taken off before you can measure any of the readings with an ohm meter. And the ohm meter will be making an appearance shortly as well. Okay, so I'll flip this over and hopefully it won't all fall apart on me. And show you the way to measure it without taking the coil out, like I'm going to do in a few minutes from now. In the center here there's usually this one's missing. It's been taken apart and probably put in something else, but there's a carbon button here that makes connection to the distributor rotor to send the high voltage through the rotor and then onto each one of these terminals inside the cap to send the high voltage on its way to fire each spark plug in sequence. Okay, so there you have it. I actually had it taped here. This is some residue from some white tape I had here, and I just penciled in some arrows to point to the center. But the carbon button sits there, and then there's a spring that connects with that. And then when I take the coil out, I'll show you where it connects to the secondary side of the coil there. But that's basically what you got inside there. Now for the measurements, if you're going to do it this way, without taking the coil out of the cap, for the primary side, over here you'll have the spade clips poking through. We're upside down, remember. So then make sure that battery supply wire, the red one, is out. And additionally, if you have a tachometer hooked up to the other spade clip or lead there, disconnect anything there. And then, see, might even be a good idea to take off the, yeah, there's the wiring harness, like I'd mentioned, that comes from the distributor housing up here. We're upside down, remember, and there's a 3-wire lead that goes into this inner place. There's actually two cavities here, if you will. Okay, on either side there, and I'll explain those clips. They do a dual purpose. On the outsides here, they're one piece. The spade clips from the top, or spade connectors, and then there's another set here on this side that goes to both of these outside ones lead to the coil primary windings, and the center one should be for a ground, if I remember correctly. And to do the primary measurement, you just hook up your ohm meter, which I'll be showing you when I take the coil out of the cap, and you just the probe on the spade clip that's on this side and this side, and you'll take your low reading from there. Okay, this is with the coil, like I mentioned, still installed in the cap. And then once you got that reading, then you have to move on to the secondary side of the coil. Okay, so it's going to be a higher ohm reading. That's if it's a good one. And you'll go from that center terminal in there, which is absent at the moment. From the center, that's your ground. Remember, take this wiring harness off. You're probably going to have to take it off anyway to get the cap off and flip it. Like I say, the coil can still reside in the cap, no problem. So to do the secondary side, then you go from the center spade clip here. It'll be for your ground, and it goes to, I believe it's the secondary side of the coil, and then 1 ohm meter lead there to that center spade clip thing, and then the other lead from the ohm meter to the carbon button here. And then you take your reading for the high side, or the high ohm reading. Thing I'd like to mention now is the little carbon button is a resistor in itself too. I've looked up several specifications. Each vehicle is a little bit different, but ballpark that the carbon resistor at probably 0.5 ohms or half an ohm. So you got to account for that when you take your reading with the coil as well. So now what I'll do is I'll flip it over and show you the other way to do it, and it's more, you could say it's simpler to understand with the thing all out of there. But what I'll do for starters here is I'll just twist these clips to show you what's going down in there. Actually, they're in there with a pretty tight fit, so you might have to get needle nose pliers and pull up on them as you hold the cap down. Okay, so now I'll explain to you here. I'll move these clips sideways to show you after you pull it out. Like, they're being there pretty snug, so the best recommendation I can give you to get them out of there, if they're kind of lodged in there tight, is get your needle nose pliers and look down in there. Don't grab it here and don't grab it here. Try to grab it somewhere halfway between. That way you equalize the pressure when you pull up on it. Okay, mind you, we're at 90 degrees because I twisted these to show you. So these clips will be down in there like that, and this is what you'll be seeing halfway there, and pull straight up. But don't, make sure that you don't pull like you're doing a golf swing or anything. You don't want to follow through and break the connection or break the wire. Okay, so there's that part of it. So like I say, to get the coil out of there, once you've removed the rest of the stuff that's on there, the ring with the high tension leads or spark plug leads, then like I say, that other cap comes off with 2 or 3 screws. Then this is what you'll see. Okay, so once you've got these disconnected, there'll be 4 screws in here as well on each corner of these laminated sheet metal pieces that form part of this coil. There's the ground for the secondary side. I hope I'm getting this right. I'm just going from memory mostly and stuff that I've done in the past. So if I make a mistake, I'll try to catch it and put an annotation there to clarify if I do mess up. So not a big deal. But anyways, this is held down in there, and there should be another lead, if I remember correctly, going from here to that to provide the ground connection to the wiring harness into the center part. And it's just a single spade clip, much like you see right there. Should be going down in there, and you shouldn't have to remove that. I believe either they're doubled up, or else that one is separate and held down with the screw that retains this ignition coil in the cap. Okay, so whether you need to take one lead, excuse me, let me back up a minute. You'll be taking out those 4 screws anyways. So you just, there's, like I say, there's the lead from the secondary side of that coil, and there'll be another one either on top of this or maybe even from the other side there. It's just a ground wire basically for the secondary side. Okay, so now once you've got those 4 screws out, these leads are loose, and whatever you're doing with that one, if it was present, then all you have to do is, once these are pulled out and not damaged, you just pull straight up on the coil and it'll come out of the cap. So what I'm going to do is I'm actually going to go one step further here. I'll do it this way. And just to show you, I'm going to open it up like a book, a page in a book, and show you what's under there and how it connects. Straight up on the coil, okay, flip it over like a book, a little tongue-tied today. And there's what you're faced with. Get the flashlight out again. And down in there, that's where the, there's 3 things that sit there. Down in the center hole there's the carbon button goes in first, and then there should be a connector spring. It's much like a little spring that you find in your ballpoint pen if you have the retractable type. And then on top of that there will be a black rubber washer. It's fairly thick and it sits right in that that little cavity, the circular cavity there. And what that does when you tighten these 4 screws down on the coil when it's installed, it compresses that rubber washer or seal, if you will, and squishes it between there, so you get a really good seal, and it keeps moisture out, condensation, and it just generally insulates the high voltage, so that the only place that high voltage gets a chance to go when everything's working properly, that is to the carbon button, which feeds your rotor and then distributes it to each spark plug in sequence. So once, if you were going to install this again, so the carbon button would have to go in first in the center, then the spring, and then the rubber washer, seal, and then you'd get this thing and then just plunk it down in there and then put the 4 screws and do up those ground wires again. Okay, that's enough about the cap situation. We'll just remove the cap from the video now, and we'll get onto the coil a bit. I'll show you another thing that I found here too as well. Is it's actually kind of beneficial that it's done this way. This this framework here comes out in 2 pieces. Okay, it's like 2-letter E's, if you will. Let's take it as easy. Anyways, they go inside there, and before I get too far along, they're laminations. They're not a solid block of steel. They're laminations of thin steel. Oh, they're only about, I don't know, 20 thousandths of an inch thick. Like take a 1/16 of an inch and divide it into 3 or 4 parts. They're like thin cardboard, only these are made of steel. And you can see they're laminations there, and most electric motors and things that you see, they're not a solid block. They're actually built up of laminations of sheet metal. Okay, so that, the way the electrical field functions is why this is shaped like it is. Those coils actually wrap around the centerpiece there. The coils of wire actually go within this the coil itself. They actually go around the center section here, and whether the perimeter has much to do with that, I imagine it does. Okay, so and another thing I'll explain to you too is another video I made here was showing you the oil-filled, the difference in the oil-filled coil. This one was in GM's was used up to about 1974. That's if it was, this is a Chrysler one, mind you, but with the breaker points ignition, smaller distributor cap, this was the kind of coil they used. And then in 75 they went to the high energy for the most part for the public in their vehicles that they bought. Okay, so the difference is this one is filled with oil. Okay, be careful, some of them might be laced with what they call PCBs, cancer causing. Okay, don't touch the oil, and if you do, wash your hands, and any part it contacted your skin right away with soap and water, hot water. Not too hot, don't want to burn yourself. And with this type of coil here, it's not oil, it's epoxy type of a glue by the looks of things here, and all those windings are in there. And I'll explain, just like I did with the other video on the other style of ignition coil, is there's 2 sets of windings generally in these things. On the primary side, which is these 2 here, they actually form a loop. Many windings, turns of what they call a coil, usually copper wire if I'm not mistaken, and it's a turns ratio. What they do is take battery voltage and they step it from your 12 volts, which goes into here basically, Okay, you've got the red is, I believe, is the battery plus terminal where you connect the battery feed wire under this cap where I was showing you. And this, I believe, is for a tachometer connection here. And this is the ground. Not sure if it ties in with the primary. I'm pretty sure it's just a secondary. But it's a turns ratio. So they go from 12 volts on the primary side, and it gets, these particular ones, they'll go all the way up to about, they claim about 50,000 volts. So in order to get that, on the primary winding side, there'll be less number of turns, maybe a different thickness of wire. And then on the secondary side, to step up the voltage, they have to have many more turns. So for every one turn, say they had on the primary side, they might have 100 or something like that on the secondary side to step the voltage up. Your amperage would usually drop, but your volts would go higher. Okay, you don't get any free electricity from anywhere. There's a compromise there. As with this coil here, it'll probably max out at 25 or 30,000 volts, whereas, like I say, this epoxy type high energy ignition coil will probably put out as much as 50,000, 50,000 volts. Okay, we can do this. I'll just put this back together here, just so you can get in case yours doesn't come apart like this one does here. Okay, now we'll get on and we'll bring the ohm meter in now. Okay, so here's the ohm meter I used in the other video as well. Same one. It's a multimeter made for automotives. It specializes for that kind of a thing. It still does a few other things as well, and I'll go over it again just like I did with the other video. There's a selector dial here with an arm on it, and you can take your choice of anything that's on the meter. As long as you're measuring whatever is within the limits of this meter, then it'll more and do its job. It's quick, it's easy. $85 worth a few years back, and it's more than made its money back to me over the years I've used it. So duty cycle is one of the ranges here. You could use that for the fuel injectors to see how long they're staying open if you've got fuel injection, or any cycling kind of an electronic thing that's within its range will tell you in percent. It's like taking your light switch in your house and flipping it on and off, and it'll tell you the amount of time it's basically on versus the time it's off in percent. Next section here is dwell. If you have the points type ignition system, you'd have to set the gap in the points, and it's got for the different number of cylinders in your engine. The tach or tachometer, you can select the number of cylinders in your engine, and it'll tell you how many RPMs or revolutions per minute the crankshaft is turning. This one has also got, I don't have the cables for it. If you bought those as an option, it's got temperature built into it. You could take temperature of, not really sure, I've never gone that far. Imagine you could take coolant temperature and whatnot with the probes that are provided, providing you had them and bought them as the option. And there's DC amps here, and then there's a diode checker. It's got an audible alarm. Diodes, they only form a circuit in one direction, so it'll beep in one direction only. So if you get no beep or a beep in both directions, you know you've got a bad diode. It should only beep in one direction. And this is the scale we'll be using. It's in green. And actually bring it up a little closer. And there's the range we're going to be doing. It's between my thumb and forefinger there. It goes from 0 ohms all the way up to 20 mega ohms. That's a lot. Tiny. And then there's DC volts here for your battery voltage, and if you wanted to check some of the 5 volt kind of stuff on a fuel injected system, it's all there for computer stuff as well. But getting into the ohms range on the when we're measuring the low ohm reading on the primary coil, will be down probably in the lowest range from 0 to 200 ohms. And by the way, it's ohms, or ohm, O-H-M. It's a measure of resistance. And without getting too scientific, it will tell you how much resistance is in a circuit or a wire or even a pile of carbon if you like. That omega sign there, it looks like a horseshoe. Right there. That's the sign for ohms. Okay, so now we'll hook it up to the primary side of the coil. Okay. Get this thing centered up. Make sure it doesn't leave the frame so we don't have any lost parts and pieces. Alright, here we go. Okay, so I've got these leads. I might as well say in this video as well, in case you don't watch the other one. Okay, alligator clips. They hook on to whatever if you can get these things, and whatever you're connecting isn't too big in diameter, or, you know, as big as your finger. If it's a small screw or something you can clamp on, they call them alligator clips. And there's the alligator jaws, and that's how they got their name. Alright, so I like to keep things reasonably organized when I'm measuring electrics and electronics. This should be the battery feed wire. It's in red, so we'll connect the red to that one. Okay, ohm meters, you can go both, or you can go either way. It doesn't really matter too much on these ones. It's not electronic, but try to keep the polarities right. So let me straighten my wiring out a bit. It's getting a bit messed up on the workbench there. Excuse me. Okay, here we go. Get those out of the frame. Okay, so we'll go here with the red and rub it in there, make sure that it's grinding away, making good connection. You'll get a false reading if there's any oxidation or any dirt or whatever on there. If it's oily, you got to clean it first. Okay, and then on this one we can just put this over here and then grind it in. Make sure that nothing's touching or anything. It's got to be separated. Okay, now we'll crank this thing down to the lowest range, the 0 to 200, and see what we get. Excuse me. One more thing, I did it again just like the last video. With the analog type of meters, when you set it up for ohms, you'd have to calibrate the meter because there's resistance in the length of these wires here. That changes the reading, as well as like this one here, it doesn't zero in. I've actually got a probe and went between these two without the wires in, and it seems to be out 0.3 from the zero reading. So what we do is we basically connect the two leads together and see what we get. And this is how we calibrate this meter. Make sure that we can subtract that with some simple math and get a better reading, especially when it comes to the low ohm reading on this coil. So I'm showing 0.3 or 0.3, so we'll have to subtract that from our reading. Okay, now we'll get back into things here. Grind it in there, get a good connection. And another good connection like so. Make sure everything stays put. Now we're getting 0.7 or 0.7. Remember, we're at 0.3 or 0.3 for the meter's calibration, so we have to subtract 0.3 off of that. Okay, so then there's 0.4 or 0.4. That's our low ohms reading. I can go up a notch, but then it's probably gonna, see, it'll disappear. If you're in the wrong range, it'll let you know. It'll either show a 1 here, but I see 0.7. And I wrote down a few things and sort of ballparked this, and what you have to do is look up the specifications for your particular vehicle. Every one is a bit different. Don't just take one specification. Get the exact same one for the distributor model that you have, and hopefully it's the same HEI system that was installed in the engine that you're working on. Okay, so for the low, as long as you've got in general ballpark figures for low, as long as you're 1.0 or lower, meaning a full 1, as this is going to be 0.4 because of the difference in the calibration of the meter, we're well within range of from 0 to 1 ohm. So we're about halfway at 0.4. Remember, you have to subtract that 0.3. So our low end low ohm meter reading on the primary coil checks out. Now on the secondary side, this connection part, this is where the seal, remember the rubber seal goes here, then the spring, and then closest to where my finger is pointing towards you on the screen will be the carbon button down inside that distributor cap. Okay, so we can do the same thing here. It shouldn't matter which one of these you connect. Oh, sorry, this one's different. I'm thinking about the oil-filled one. We got to get that ground wire happening here. Sorry, my mistake. There we go. So we don't use these. These two are just for the primary coil reading on the HEI or high energy ignition for General Motors. So now we need to make a connection between this ground wire and the output part of this coil for the high voltage output that is sent on your way to your distributor rotor. Okay then, so we can just hook up our black to the ground. Black is ground, red generally, in general terms, depending on what country you're in. North America, general black is ground. Always check the circuit you're working on. The vehicle, they might be a bit different. You got an import car or whatever. This is just for this the high energy ignition coil that General Motors made back starting '75. Okay, so we've got that hooked up onto the ground. Now we're going to do the high ohm reading. I could just go in with the Alligator Clip, but I'm going to show you, I'd mentioned in the other video that these unscrew. Both of them do on the black and the red test probes here. So you can have the Alligator Clip if you can clip on, but if you have to get in somewhere small, there's excuse me, I'm a little caught up in the wiring here. Okay, here we go. See, this just screws on here like so, and then you just unscrew it, and then you've got a probe to get down to smaller parts here. Okay, it's just like a small nail. So I'm just going to park the Alligator Clip head off to the side, and we're going to scratch into the secondary side here to make sure we make a good connection here. Okay, so scratch around, make sure that it's all like, and hold pressure on it. Okay, now it's the meter set at a way too low a range to get anything. If it indicates zeros or just this one, means you're out of range, so we're going to crank it up one range at a time. That was 0 to 200 ohms. Now we're going to go into 2K. K just means 1,000, so 2K is 2,000. So I believe it won't go any higher than 2,000, but below it will. Okay, we're still seeing a 1, which means nothing, so we crank it up another to another range, if you will. This one shows 20K. K is 1,000, so 20,000 ohms is maximum this range will do. We're getting a reading, but I'll just go one more to see what it does. Okay, we're losing decimal spots to the right, and if you go up here, we're getting virtually little to nothing. Okay, we'll back up excuse me, to the best range we can get with more parts, should I say digits to the right of the decimal. Okay, so we got 8.56. Like I mentioned in my other video, it complicates the mind some ways. If you work with these long enough, you'll get it. I understand it, but the easiest way to figure this, like I'd mentioned in the other video, was think about currency. When you think about money, things become clear. Either you got too much of it or not enough. Okay, so what I'm going to do is add a 0 onto the end here, and I'm going to change that decimal to a comma. Now we could understand this as, say, dollars, yen, marks, euros. Take the currency where you live, whatever that might be, and then so we have 8,000 with the comma, 560. Okay, but we're dealing with ohms, not money. Just think of it as money. It makes things much easier to understand. Okay, remember we have to subtract decimal 3 because the meter is out of calibration for the 0 point. So if we take 3 away from that 5, we get a 2. So in essence we have 8260. So 8,260 ohms. And now to fall within the range, it goes anywhere, and depending on where you look, I've seen anywhere from 3,000 ohms to 20,000 ohms. It's quite a wide range for the secondary side of this coil. Another one was saying 6,000 to 30,000 ohms. So if you go all the way from 3,000 to 30,000, that's well within those limits. Now remember, we're going directly to the coil. We don't have the carbon button resistor in the circuit. So then you'd have to probably do a calculation, or I wouldn't even say go that far, but if you're measuring it the other way, like I say, through the carbon button, and then with those leads that are off to the side on the top of the cap, you would get a different reading from the same coil, because that carbon button has a resistance of about half an ohm, give or take a little bit, so that's going to change this reading. This coil will read a little bit different, but I'm almost certain that it will fall well within that range of depending on what your specification is, but I've got anything all the way from 3,000 ohms to 30,000 ohms, so like you see there, even if we took this whole thing away from the right side of the decimal, it's still showing 8,000, right? So anything in that range is good. So this thing checks out as far as ohm meter readings go. If there's a short in these coils to ground or something, you can check with that too. You can take your probe and go to the ground frame on it anywhere you like. This one probably won't show anything because it's all insulated from the coil and everything else, but there's been strange things happen over the years, and I don't discount anything. Things just, you learn something new every day, it seems, and problems that I've never seen before seem to jump up at you every now and again. So there you have it, folks. That's basically how we measure, or I measure anyway. resistance using an ohm meter on an ignition coil. Like I say, there's another video there for the oil-filled ignition coil. You can go to my channel, and if you want to look at that one as well, it's pretty much the same thing, only the readings will be different, and as well as the coil will be looking a little different. Okay, back to that range again.